Hi everyone, this is Mahmoud Rahman. I am a PhD student at University of Louisville. For more than a year now, I have been doing research on the role of indoor climate in COVID cases. We found that COVID cases are strongly modulated by indoor white bulb temperature. This research gave me a different viewpoint of COVID dynamics. That's why I have been tweeting a lot for a year now. I'm not a vaccine expert, but I can see how vaccine plays a role in the dynamics. My observation tells that vaccine helps in reducing sickness and deaths in non-virus favorable climate, but in virus favorable climate, vaccine actually helps in virus spreading. While it may help in reducing sickness and there are some evidence of breakthrough cases as well, however, most importantly, vaccine helps in virus spreading, especially by the partially vaccinated people. To prove this hypothesis, we need to look at COVID cases among unvaccinated group and COVID cases among partially vaccinated group in virus favorable weather condition. Here I found a study that can help us to understand this. This is published in Nature Medicine in 14 June 2021. They studied COVID cases in Israel from January to March when vaccine rollout was happening and Israel had a lot of COVID cases. They made a same-sized and masked pair of vaccinated and unvaccinated COVID-infected group. They divided vaccinated group in two separate groups, partially immune and fully immune. They found that the dominant variant alpha is higher in the partially vaccinated group, as you can see here, compared to the unvaccinated group. While alpha variant are in equal number in fully vaccinated group and unvaccinated group here. So therefore, I found this study really very helpful, and I believe we can draw some useful conclusion from this study. But this may not be very intuitive to get the whole information, because when they are doing a masked pair, we may have lost a lot of other information. So that's especially when you see in the green bar, the gray rectangle, you see the this variant, wild type variant, is lower number in vaccinated group compared to the uncontrolled compared to the control group. That means it appears to be that one variant is in higher number in the vaccinated group, while other variant is lower number in the vaccinated group. So to my understanding, that if vaccine helps in virus spreading, then we should be able to see all variants are growing a higher number in the vaccinated group. So here I made a design of the thought experiment. You can see on the left side and also the right side, but I will explain the left side first. So I made an equal size of the population, say 1,000 people in vaccinated group and unvaccinated group. This is the control, is the unvaccinated group, and case is the vaccinated group. And say I assume that a number of cases should show up at a higher number in the vaccinated group. So every variant I made higher or longer bar compared to the vaccinated group, compared to the unvaccinated group. So these are the uninfected, and these are the infected people, and these are the infected people here in the unvaccinated group, and these are the uninfected group. Now if I want to make a masked pair, then I have to make this infected group to the control group. So one way I can do that is I can compress it down to the same size. That means I can reduce number of people proportionately so that I can get the same size, and then I can compare the vaccine variant. So if I compress this bar, then that appears like this. That means the number of alpha variant is higher in the matched pair of cases, I mean the vaccinated people. And you can see that even though this gray bar was longer or larger, you can see after compression this becomes smaller. So this really matched with this plot here. But this is a kind of one kind of experiment. We need to think about other scenario as well to eliminate that those are not the case, but this is the case. So from this explanation, you can see that vaccine helps in virus spreading. Say another scenario, just I flip the case and control group and made the same experiment here. So the assumption right now is uh, the infected people, actually this should be here, the bar should be here. Anyway, so the idea here is now the infected people will be higher in the unvaccinated group, and infected people will be lower in the vaccinated group. And if you do the same thing and then you do the compression, and you can see that you can see the same outcome, but this is now the matched pair of the control group. That means the alpha variant, the proportion of alpha variant is higher in the control group. But our observation does not, I mean their study observation does not support that. I mean we do not see that the alpha variant is higher proportion in the control group. Rather we see the opposite. So from these two comparison, we see that this cannot be happen. Only this can happen because this match with the outcome of their study. Now let's think about the other scenario. So this is the one scenario we already got, that this can be a possible outcome. And another scenario is, again, this group is higher, the control group, I mean infected people in the control group is higher, but at this time instead of making it larger, I had to make it shorter, and the other group, like the other variant group, takes a significant portion compared to the number one case here. And if we do the same thing, like squeeze in the same size of this case group, and you can see that the proportion of alpha variant becomes lower. So this thing matches with this one. So the alpha variant is higher in the case group, alpha variant is lower in the case group, and also the control group, and also this wild type is higher than this one. So this two scenario matches with this one, but we have to look at very carefully is that from all these cases we see that the alpha variant dominates significantly. So if I can see here, it's the lowest proportion is 83.4%. That means more than 80%. So it clearly indicates that other proportion of the variant will be lower. That means this cannot happen. In this case, the alpha variant, the proportional alpha variant is lower. If you need to increase this one, then you will not be able to see anymore that the alpha variant in the control group is lower. Then it will go up. Then it will not match with this one. So that's why you can eliminate the number 2. So this is not the possibility. The only possibility can have is the number 1. So from their experiment, we can say with confidence that the virus helps spreading the virus, because virus helps to make people more of those variants, and then that can spread to the unvaccinated people, and that can easily spread to the virus. I think if you look at the pattern everywhere, especially in the virus favorable climate, you will see that this is true for everywhere. For example, in Israel, you can see in UK, in January, February. You can also see in Chile. You can see that in India. You can see in Sicily, and you can see in Indonesia. I think in Malaysia, and also I mean everywhere. You can just try to see even, and you can match the vaccinated curve, and you'll be able to see that pattern. But there are some also exceptions. For example, in USA, I'll show you in a minute here. So this is the exception. So during vaccine rollout, we saw that the cases were dropping, but then again it goes up, way up, way up. Actually, this plot is a few days back, so it should go more up here. So here actually it worked much better compared to the last year same time. You see it come down to here compared to here. So it is almost was going to like we're getting normal situation. We are hoping that we're getting the normal situation. Then situation got worse. So vaccine helps in non-virus favorable weather condition. So so vaccinated people got the virus maybe, but they become well within a few days. They had probably side effect. They probably have the COVID symptoms, but maybe we call it side effect. Or, for example, in clinical trial, there are cases that is called as the COVID suspected but not confirmed. So they tested in the nasal swab test, they become COVID negative, but they had COVID-like symptoms. So that termed as unconfirmed COVID cases. So my understanding is that if body has some dormant virus in the body reservoir and vaccine triggers that virus to replicate somehow, then it could be possible that the vaccinated people who has the COVID-like symptom may not show up COVID positive in the nasal test, nasal swab test, but it could be possible that they can pass through or transmit virus through their stools. So in unvaccinated, if a person become COVID positive, have COVID-like symptom, and he stays in home, and there are unvaccinated kids, for example, or other people, then and they share the same toilet, it could be possible that uh, they can transmit the virus. So this is my kind of understanding how virus can be spread through vaccines. I'm not sure about that. Vaccine scientists can figure that out. But what the point I'm making here is that even though this is the way vaccine can make people make the virus spreading, and as I said earlier, that vaccine helps someone to get not so much sick. It can reduce sickness, and it can helps to prevent hospitalization. That means vaccine helps, but in non-viral favorable condition, it may transmit to other people. But because of the virus, non-virus favorable environment, the other people are not getting sick. So that's why virus vaccine helps to reduce the overall sickness. So that's why I feel like this is the perfect time to vaccinate people. If we can vaccinate a significant proportion of the people and if we can reduce the sickness, it could be possible that we can eliminate the virus. But again, if you do the vaccination in the virus favorable climate, then maybe it helps to the vaccinated people, but it can also transmit to the unvaccinated people, and they can be very sick, and they can go to the hospital, and they may die. And I believe this is the reason USA had a very high number of COVID cases during this summer compared to the last summer. Our hospitalization in the last summer was 60,000, the peak, and the hospitalization was 60,000, and now we are having hospitalization at 100,000. I think we are at a peak now, but still this is a very big number. Say before this pandemic, before this surge, around 50% of US citizens has had double dosed, like full immunity. That means this virus is being a serious issue, if I would say, among the rest of the 50%. So the 100% people made the virus surge during the summer last year, 60,000. Now we can compare how dire situation right now. And I would say this is perhaps because of this vaccination effort. So I wanted to explain this study done by the group published in Nature Medicine, work in Israel COVID cases. I think that study really needs some attention, and I would request to pay some attention and figure out if I'm really true or not. Because if if vaccine helps virus spreading, that means we need to make some mechanism or some kind of guidelines so that people who are vaccinated, if they show symptoms, they must quarantine themselves, and they also should do for a stool test. For example, if they become negative in their swab test. I think this is really important, and if we can keep this in mind, I believe our next winter will be much better. Now virus is going down. I believe it will go down for a month or so, and some part of USA will go down, will continue to go down, and some part will go up again in winter. So when it's going down, you may keep going on the vaccination effort, but when you see the cases go up, you should stop vaccination during that time, or if you continue vaccination, you should be worried that the person who are getting the COVID symptom should not should be quarantined and should like do the stool test if their nasal swab becomes negative. I hope this research, this explanation will help. I'd like to thank for your attention.